Good morning, all of you, and welcome to chemistry class. Today, I'm going to start a new chapter of chemistry, that is D and F block elements. Now, let's start a chapter. What are D block elements? D block elements are those elements in which last electron enters into the d subshell of penultimate shell, that is n-1, are called D block elements. It contains 10 groups, that is from 3rd to 12th group, and the D block elements lie in between S and P block elements in the long form of periodic table. D block elements are also known as transition elements. Transition elements are those elements which have partially filled d orbitals either in the most stable oxidation state or in their elementary state. That is, a transition element should have partially filled n-1 d orbital. Okay? Or we can say that having electrons between 1 to 9. Remember that all the d block elements are not transition elements, but all the transition elements are D block elements. Strictly speaking, transition elements are those elements which have partially filled n-d subshell in their elemental state or in their common oxidation state. For example, copper, which is having atomic number 29 and electronic configuration of copper is argon 3d8 3d10 4s1. It contains fully filled d orbitals in its elemental state, but copper shows +2 most stable +2 oxidation state, and in that oxidation state it contains partially filled d orbitals, due to which it is regarded as transition element. But some other elements like zinc, cadmium and mercury, they do not have partially filled d orbitals in their atomic state or in their most common oxidation state. So zinc, cadmium and mercury, they are not regarded as transition elements. Okay, so all the d block elements are not transition elements, but all the transition elements are d block elements. Zinc, cadmium and mercury, they are only regarded as d block elements. Okay, d block elements lie in between S and P block elements in the long form of periodic table, and the general electronic configuration of d block elements are n-1d 1 to 10 electrons and ns 1 or 2 electrons, and noted down that half filled and completely filled set of the orbitals are relatively more stable than the partially filled d orbitals, and the consequence of this factor is also reflected in the electronic configuration of chromium and copper in the 3D series. Okay, in case of chromium, the atomic number of chromium is 24 and expected electronic configuration of chromium is 3d4 4s2. But instead of this electronic configuration, it shows its electronic configuration 3d5 4s1, which is the exceptional one to acquire this extra stability, as it acquire the half filled stable electronic configuration after this. Okay, So, half-filled and completely filled set of the orbitals are relatively more stable. Similarly, copper atomic number 29. Okay, in this case also it shows an exceptional behavior in its electronic configuration. Okay, and its electronic configuration is 3d 10 4s 1. Okay, and there are 4 transition series of elements which are called first, second, third and fourth transition series. In these series, 3d orbitals, 4d orbitals, 5d and 6d orbitals are filled up respectively. In 3d series, last electron enters into the 3d orbitals and it is called as first transition series. Okay, from scandium to zinc, or we can say that from atomic number 21 to 30. Okay, and 4D series, last electron enters into the 4D series and it is known as second transition series from yttrium to cadmium, from atomic number 39 to 38. Okay, or we can say that it contains 10 elements. And in 5D series, last electron enters into the 5D orbitals and it is a third transition series, okay, which consists of lanthanum and elements from hafnium to mercury, from atomic number 72 to 80. And fourth transition series, which is also known as 6D series, where the last electron enters into the 6D orbitals. Okay, and 6D series consists of actinium, atomic number 89 and 9 other elements from Rutherfordium to atomic number 112 UUB. Thank you students and have a nice day.